since I discovered ChatGPT, I've been trying to use it for generating YouTube titles and thumbnails. But these attempts would usually lead to a spectacular failure because ChatGPT sounds as unique as a corporate leaflet. And it's always one of these words: uncover, unleash, unlock the hidden potential or creativity, and so on. You don't even need an AI detector to spot people who are using ChatGPT. But here's a really interesting thing. There's a very simple and easy procedure that allows you to significantly improve large language models and turn them into an expert for YouTube titles. Or you can turn them into an expert for your business, make them sound exactly like someone your customers would like to talk to, and so on. And it works for any large language model. This one thing that unlocks the hidden potential of these LLMs is this one thing that makes LLMs much smarter is called fine-tuning. So what is fine-tuning and why should you care? Fine-tuning a model refers to a process of adapting a pre-trained foundational model such as ChatGPT-4 or Llama to perform a new task or improve its performance on a specific dataset that you choose. The process typically involves supervised learning, and I'll explain what that means soon. In this video, I'll show you how to fine-tune Llama 2 with 7 billion parameters, Meta's latest large language model trained on 40% more data than Llama 1. Also, I'll use a dataset that I've created with around 100 good YouTube titles. And the end result will be a customized, fine-tuned model that will be capable of suggesting much better YouTube titles than the ones that I get with pre-trained models. I'm also going to explain code step by step, and you can find the link to Google Colab notebook in the description box. So in this video, I'm going to teach you all the necessary concepts that you need to understand in order to be able to fine-tune your large language model on your own. So let's begin. Before you open a Google Colab notebook, you're going to need a database for fine-tuning. You can find open public databases on Google Dataset Search or Kaggle, or you might want to create your own like I did for this video. Once you open Google Colab, first thing you need is to install Hugging Face's Transformers library. It's a library that allows you to download, train, and fine-tune pre-trained models. It also supports different modalities like NLP, computer vision, audio, and multimodal like visual question answering. Also, you're going to have to install Xformers library in order for it to work. Next, Dataset library will allow you to load a dataset in JSON, CVS, text, and other formats. CRL library will allow supervised training of the model. And if you have a structured dataset, you need to implement this type of training, which means that your dataset is formatted in a certain way. For example, Alpaca's dataset is always formatted with 2 columns, one for instructions and the other one for response. This is what Orca's dataset looks like, and this is the dataset that I'm going to use. Then Hugging Face's PEFT library. PEFT, or parameter efficient fine-tuning techniques, fine-tunes a small number of extra model parameters or weights while freezing most parameters of the pre-trained large language model. This is important because fine-tuning entire LLM would require incredible hardware and it would be energy consuming, but with PEFT you can fine-tune a giant LLM on a regular consumer GPU. LoRa, or lower rank adaptation of large language models, is a specific method. It focuses on freezing the pre-trained model weight. And finally, bits and bytes and accelerate libraries are going to be used for quantizing a model. What is a quantized model, you might ask? Quantization is a technique used to reduce the memory footprint of a model and improve its performance. It involves reducing the number of bits used to represent a number or a value. In the context of large language model, quantization reduces the precision of model's parameters or weights, making the model much smaller in size, consuming less power, and allowing it to be trained faster. Full precision large language model typically uses 32-bit floating point numbers, but a quantized model is using 4-bit or 8-bit integers for precision. Once you've installed all the libraries, it's time to import all the necessary modules and to log into your Hugging Faces profile. You need to do this in order to use Meta's Llama 2 model. If you didn't already, you should request the access to Llama's 2 models on their official website, and you should use the same email that you've used for creating your Hugging Face profile. Lastly, under your account settings, go to Access Tokens and copy-paste the token into Google Colab notebook. Next, let's specify which LLM you want to load by copy-pasting the name of the model from Hugging Face's website. Load the model. In this step, you're going to create an instance of the Llama 2 with 7 billion parameters model. By setting parameter load in 8-bit to true, you're going to load a quantized version of the model. Also, let's load a Llama 2 tokenizer. And we can see that the quantized version is only around 7 gigabytes, whereas the original full precision version of the model is around 27 gigabytes. Helper function. Print trainable parameters is just a helper function that will print out for you how many trainable parameters there is in the model. Okay, now let's use Transformers pipeline method to check how good Llama 2 is. As you can see, I'm formatting my prompt template as I mentioned before with separate spaces for human and instructions. And this is a right way to prompt Llama. My prompt is: you're an expert YouTuber. Give me some ideas for a YouTube title for a video about fine-tuning LLM. And let's see what happens next. And we can see that Llama 2 is a fan of a phrase unlocking the full potential, just like ChatGPT. So the results are fine, especially for a model with 7 billion parameters, but they're still too generic. In this step, you want to define LoRa configuration with LoRa config method, where you'll define LoRa parameters for efficient training. These parameters that you see are pretty much default for training Llama models. One thing to keep in mind is that the target modules vary from model to model. Lastly, with get PEFT model method, you'll wrap base model and you'll get a trainable PEFT model. When you call that helper function, you'll see how many trainable parameters there are, in this case around 0.12%. Now load the database that you've previously going to drop in Google Colab Notebook. And finally, for training, I'm going to use SFT trainer or supervised training. And to remind you, you need to use this trainer if you have structured dataset like human, response, etc. But before instantiating trainer, you need to define training parameters, which again, here you can see default values, but you can play with them if you want. And once the training is complete, you can save the adapter in whatever folder you pick with this line. So now what? Now that you have your LoRa adapter, what can you do with it? How can you actually use it? And how can you talk to it? In order to make that possible in this last step, you need to merge the base model and your LoRa adapter. And this is a very simple step. First, you need to reload the base model, in this case Llama 2. Now pay attention to what I'm about to say because this is very important. You need to reload the full based model, not the quantized version, because as of right now, it's not possible to merge quantized versions of models with LoRa. And I had to learn that the hard way. Now you need to load your LoRa adapter, and finally you're going to use the merge and unload method to merge these two. And here I am saving the merge model locally, which you can do as well. And now in the last step, I'm going to test the fine-tuned model by using the same function as before, and I'll use the same prompt. You're an expert YouTuber and so on. And we got as a result, fine-tuning ChatGPT is incredibly easy and fast. Here's how to do it. So we don't see any generic unleash, unlock words and so on. And this is actually a great response and good idea because in my database with good YouTube titles, I have included a lot of titles that are supposed to make the viewer feel curious. Curiosity is known to be a clickbaity emotion, and here's how to do it is a great way to make the viewer feel that. So I believe that this title is great, and fine-tuned version definitely works better than the default one. As a last step, you can save it to your Hugging Face hub, and then you can load it, and whenever you need it, you can use it again. So here's how you do it. First, you go to your Hugging Face profile, create a new model, give it a name, copy-paste the name to your Google Colab notebook, and use the method push to hub to save the new model. And congratulations, now you have your own smart fine-tuned model that you can access and use whenever you want. So thank you for watching and have a good one.